We call this the old man. This is geobacter growing on an electrode. It's been on there for over 12 years, and all that time it's been making electricity. You can power small electronics that way. A calculator, a watch. You don't need batteries. It is an honor to have one of the Geobacter species named after me, but in the lab we don't call it Geobacter lovelyii. I banned that. The more iron it used. Every couple of years we discover something new about Geobacter that has some practical applications. Geobacters are beneficial bacteria that live in mud where there's no oxygen.
You can actually get your own dirt from your backyard, from garden store, from a local pond, and pretty much any of the dirt will have some kind of geobacter in it. And slowly the geobacter will feed off of the mud and create electricity in the process.
We found that geobacter produces wires. They're made out of protein, but they function very much like a metallic wire that we use in our wiring in electronics. It eats rust, iron oxide. It uses its electrically conductive wires to put the electrons onto that rust. Also, it can use the wires to electrically communicate with other microbes.
This is a very niche field. It's a very different kind of field than what infectious disease is, and that's usually what people perceive microbiology to be, just be infectious diseases, whereas there is an environmental side, and I really like that.
We'll find a lot of geobacters in rice paddies and other environments where microorganisms use those electrons to convert carbon dioxide to methane gas, which is an important greenhouse gas. So there may be ways to prevent that and not make free methane gas that's just released. If we could capture it, it's great. It's natural gas. So we can use that for cooking, for heating, eventually probably for automobiles. We're really interested in the wires that geobacter makes because we have a really emerging problem worldwide in electronic waste. Geobacter wires are the ideal component for disposable electronics. It's a renewable, sustainable material with no toxic components, so we can make sensors that can be implanted. The body won't reject them because they're a natural protein material. We can couple the geobacter wires with the living microbe. So now you can have a living system that powers itself.
It's really kind of awe-inspiring and also very surprising for the whole research group. Sometimes the results are so far off from what you expected. Sometimes you don't always want to give those to your boss, but sometimes it turns out that's the better result.
Recently, we discovered, much to our surprise, there are some other microorganisms that also can produce electrically conductive wires. Just at UMass alone now, we have colleagues working on this in polymer science, chemical engineering, electrical engineering, physics, and I'm probably forgetting one or two others. So this is what's so exciting about this new field, is the interdisciplinary nature.